Good afternoon, everyone. If you're just joining us, you're welcome. We just want to try and wait for other students to join us so that we can start. But in the next 2-3 minutes, we're gonna kick start the presentation, and the tutor that will be passing the message to us today is no other person than Mr. Ajayi Babajide, popularly known as Boaz. So we are going to be looking at past questions on physics in order to prepare a student and for you to stand out among your peers. So just try to calm down, get your writing materials, your notebook and your Bible, your calculator if possible, so that we can journey together within the next 1 hour. Thank you once again. Don't forget to log in to www.SciAfrika and try to download. Try checking the app, download the app on your system, and ensure you register so that you can enjoy a lot of courses on different subjects, being mathematics, biology, physics, and chemistry in the indigenous language. Thank you. Very soon we are going to start. Um, can you just please call your friends, message them that we are online, we are live now, so that everybody can partake and can benefit from this lecture. Lẹ́ẹ̀kan sí a kú ìsinmi ìparí ọ̀sẹ̀. A kò fẹ́ dúró fún ìṣẹ́jú bíi mélòó kan ká tó bẹ̀rẹ̀ kí gbogbo wa ká lè bá a ní oore ọ̀fẹ́ àti àǹfààní láti kọ́ ọgbọ́n pàtàkì àti láti gbáradì fún àwọn iṣẹ́ tí tàbí ìdánwò tá a fẹ́ ṣe láìpẹ́ yìí ti JAMB àti WAEC. Nítorí ìdí èyí à ń rọ̀ wá pé láti sọ fáwọn ọ̀rẹ́ wa tó wà ní àyíká àti àyídà tàbí lórí WhatsApp kí wọ́n tètè join báyìí. Hello, Boaz. Can we start now? This is 12:11. 12:11.
Okay.
Thank you.
Okay, sir. Let's confirm that you can hear me clearly. Ṣé ẹ lè gbọ́ wa dáadáa yékéyéké?
I can hear you from my hand here.
Okay.
Mozuma Augustine, can you hear? The CEO, can you hear?
Our
Let everybody
learners, which are very important to us. Can you
just quickly
hear
unmute.
us?
We can hear.
Okay.
Good. So this is going to also be a very interactive class. SciAfrika don't want to hide anything from you when it comes to your exams, when it comes to how, we want you to pass. That's our aim. We want to build a community of students that are not scared of their exams. And so we are here to answer any question at all. So if there's any way, anyhow, you have seen the questions and you need explanation, please call us back, let us know. But we are going to start with some basic tip on how we can we can pass our exams in JAMB. JAMB's examination is for senior students. When I mean senior, I don't mean that you are in SS3, you are this or you are already. It means that students that can think, students that can solve problems. It means akẹ́kọ̀ọ́ tó lè ronú. That's why they will not just go to your textbook and pull up any question like that and come. They want you to know that okay, they want to see what are they actually looking for. They are looking for students that can think around outside the box and can know what to do whenever they see a problem. And that is it. Not just that. When you know what to do, number one, you are senior students. That is, know what to do. That is, you know what, you know your onions, you know what to do. You know how to solve solutions. You know how to solve problem. Immediate solution that you can encounter. You know what to do or solve problems. And these are the set of students that can effectively pass JAMB. You know, this is one of the very important steps. You need to know how to solve solutions. Don't look for questions that are just in your textbook and you move ahead. And that's why SciAfrika has provided you the platform with courses. You can't just solve past question and say, okay, I'm cool. No, you need to read. You need to know where it all comes from. You need to understand concepts of anything, especially when it comes to sciences. You can just read history and just know that it might not go beyond that aspect of history. When it comes to science, you need to know how it all started because it can be twisted. Questions can come from any angle at all. But if you don't know the basics, you will be sweep off your feet, and that will not be good. That will not be good. You just be, and that's why this is not the ultimate solution. The ultimate solution is that what? Go back to read, go back to study, and which we have provided a platform for you, SciAfrika.com. Please visit it and let's know. That's one. Number two, be time conscious. Be time conscious. Your time is very, 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 very important. When you, as a JAM student, when you just think you have luxury of time, please think again. Luxury of time when it comes to JAM is nothing. You don't have it. The time keeps ticking. As you keep solving, keep looking at your time. But the beautiful thing is that what? Are you a student that can solve a problem within a split second? What do we mean by that? It means that you can save time from some little questions and pour it on the one that you think is hard. There are some questions in physics that you don't even have to think for 1 second for you to know the answer. That is even after you have studied concept. I don't know if you are getting me. So be very, very time conscious. Some students, it's not because they don't know what to do, but because their time run out. And some of you that have even had JAMB exams before, you will know that the major problem with major students is time. And and you have to be time conscious. Don't just know the question. Know how to solve it at the smallest time. Know how to solve your questions or your problems at the smallest of time. At the smallest of time. Number three, seek every help you need before your exam. Seek every help you need. Every help. What do I mean? Whether AI help, tutor help, website help, any help, every help you need before your exam. Take it because on that day it is just you and yourself. I won't just these three, then we'll dive in deep into what we are here for. Seek every help you need, and South Africa is here for you, and that's the beautiful thing about it. This community is created for students that have that are ready to learn and make sure that they don't have any issues when it comes to their examination, be it JAMB or WAEC. But this is our platform is ready to support you through your journey. Even it's even beautiful that even you can still be part of the community when you get your admissions and we can still help you out. And And that's how easy we are. And that's how wonderful we want to help you. So these three things it will be just one of my basics I'm going to start with when as we look at these past questions together. Um these past questions are real past questions we dived in from that we got in from the JAMB, and they are what was given to students many years ago or some years back. Um, and your ability to understand their concept, as I said earlier, will help you to solve these questions accurately. We help you to solve these questions accurately. So um, I want to start 12:18. Number one question says that a few grains of table salt were put in a cup of cold water. I want us to understand these words very well. A few grains of table salt is put in a cup of cold water, kept at constant temperature. Constant temperature. These are keywords you should note whenever you are answering some questions. And left undisturbed. Eventually, all the water tasted salty. All tasted salty. This action is due to something. If you have visited um, um, the SciAfrika platform and you go under physics, under the study, particular study, we have looked at this aspect very well. That when if due to be solved, they didn't just put in a cup of water, they kept it at constant temperature and left it undistributed, kept at constant temperature and left undistributed. Eventually, all the water tasted salty. This is an action of what? Is it a convention? Is it an osmosis? Is it capillary? And is it diffusion? Is it diffusion? So what happened to this salt of grain that is put in a cup of water, kept at constant temperature and left undistributed? What happened to it that eventually all the water will taste salty? It can be convention. Convention is when it is involved and air tends to move, from one part to another. It can be osmosis because it's going to need a what semi-permeable what membrane. Is it capillary? So we are left with two. Is it capillary or is it diffusion? What is capillary? Capillary action is the ability of liquid to flow in a narrow space without the assistance of anything at all, but it can flow within a narrow space. Ability of liquid, that is the ability of that's capillary. So, but what is diffusion? The movement of what? Matter, whether solid, liquid, gas, through a movement of solid, liquid, gas from a region of what? High concentration to a region of what? Low concentration. So, what actually happens in this context? What actually happens in this context? If I were you, will I pick capillary or I will pick diffusion after knowing their definition of these things? So we are left with two. We have removed convection, we have removed osmosis. Will I pick capillary or would I pick diffusion? Because the salt was in a cold state, put in a cold cup of cold water, kept at constant temperature at that point, and we did not stir it together for it to mix up. We did not. But eventually, the water, all the water, entire water, was tasted salty. What action was that? It was diffusion. It diffused from a region of what? High concentration in that water to a region of what? High lower concentration in that same water. It did not pass, it is not capillary because it did not pass through a narrow what? A narrow tube. They did not say it passed through a narrow tube here. No narrow tube or salt bridge was happening here. It only passed through it only moved from a high concentration of that water to a low concentration of that water. So I don't know, is this clear? Okay, so moving on. A force required to make an object of mass m traveling with velocity v turned in a circle of radius r is what? Turned in a circle of radius r. So breaking this down, we are looking at circular motion. We are looking at circular motion. And if you are okay with circular motion, especially when you visit the SciAfrika, we have listed a list of formulas that are needed in the topic circular motion. Circular motion. There is nothing like this. There's nothing like this. But how do we know when you visit this topic? When you visit this topic, the most formula that we use under this topic called circular motion is this. This is the answer to our question. And you can only know that when you know the topic in basics, which is circular motion. I don't know if I'm clear. It's not this either. Because if I should draw and the ball was moving, and this is our radius r, and they asked us the force required to make an object of mass m traveling with velocity v. So this there is a velocity is traveling with here. There's a velocity is traveling with here, which is v, turned in a circle of radius r. So it's going to be this. This is the formula we can use for that. I don't know if I'm clear. And you can only find the topic in circular motion, and which I also want to urge all our students that now you see why past question might not really be the best because of you don't understand the base. If I just come across these questions and I don't know even the topic is coming from, I'm going to lose. So me knowing where it's coming from, give me an edge to be able to answer the question. I know that this topic is coming from somewhere from diffusion because I have understand their concept. This one too, I know that this is likely a circular motion question, and I can understand the formulas that are under that basic question. So please still follow SciAfrika for more. And there is another one here. What did you say? A machine gun with a mass of 5 kg fired. This is one of the questions that student under physics we love to, we love to know about when it comes to calculations. Okay, they said a machine gun of mass with a mass of 5 kg fires a 50-gram bullet with a speed of this. The recoil speed, we just did a course on this too, of machine gun is what? Now, there are formulas to this too. This is found under the topic of what? Momentum. Momentum. And we will find it under momentum. And what is our formula for this? We have, because there is a gun and there is a bullet. These are the two masses. And so we have something like this. MAVA equals to MB VB. If MAVA equals to MVVB, this is, constant law of momentum now, that whatever momentum is on the right should be also on the left. This is the basic concept of this. But what is MA? Our MA here is that of a gun. Is that of a gun. 5. MA is 5. Mass of gun, 5 kg. Fire a bullet. Bullet, that's MB. And MB is what? 50 gram, but we can't use 50 gram. Why? Because our unit should be in what? Kg, and that is what? 0.05 kg. I don't know if you guys are following me. So they said, what is VA? VA, if we read it very well, we can't find VA. Are you guys following me?
Yes.
Correct.
Yeah,
Thank you.
yeah, we,
There is no VA, that is velocity of mass of the gun is not told here. The velocity of the gun is going to be our recoil, and that is the recoil speed. That is the recoil speed. So this is what they asked us to find. So, but what is VB? What is VB? Definitely VB is 100 because that is the speed of the bullet. 100 meter per second. Having known all of our units that we need for this formula, we come back and say MA is what? 5 times VA. We need it. Then we say equal to what? MB. MB is what? 0.05 times what is VB? 100. So if we look at this very VA will be equals to 5 divided by what? 5 divided by 5. Then VA will be equals to 1 meter per second. Is this clear? Let's look at 1 meter per second. So we have
I think there's a student
good,
raising his hands.
good. Thank you. Yes, sir. Yes. Who is that?
Can you speak, Augustine?
Please, the um, the mass is supposed
Yes.
to be 0.05 because it's divided by 1,000 and 0.05. I mean,
Yes.
supposed to 0.005.
No, now look at
Okay,
50
50. I thought
divided
it was
by
5.
1000.
Okay, I thought it was 5. Thanks.
Thank you. Can we go? Are we cool?
Yeah.
Yeah. Okay. So can we move on? So this topic you're going to find it under momentum. You're going to find it under momentum. Visit our website and study this part of physics. The formula is there. I think we have also solved many questions about this there. You can just look at it. Then another one is, let's look at this. Many students run from simple pendulum because of, I don't know, but we have also broken it down in our website. Let's go on. If in a simple pendulum experiment, the length of an extensible string is increased by a factor of 4. By a factor of 4. Its period is increased by a factor of, then the question marks come. So they are trying to let you to find the relationship between what and what? Between experiment, the length of the invisible space is increased. Between length and period. They are trying to find the relationship between what? Length and period. Period in simple pendulum is T, capital T. Length in simple pendulum is what? Is L. So what is that formula that bind both of them together? The formula that bind both of them together is T equals to 2 pi raised to power L over G. This is it. This is what binds both of them together. Okay, so if we already have this, we can take out so many things and just see that T, he said if the simple pendulum experiment, the length of the inextensible string is increased by a factor of 4. So length is increased by a factor of 4. We have another one that says T1 equals to T2. That is period 1 equals to period 2. Then L1 over L2. If this is it, then L2 equals to 4L1. What do I mean? They said that the length is increased by factor of 4. Normally, this is how it should be. That is, sorry, I'm coming down. That is, T1 equals to the root of L1. This is how it should be. But they have now said that the real L2 is what? T4. So what will we do? We will say that T1 over T2 will be equals to the square root of L1 over L2 will be replaced by this 4L1. L1 can cancel L1. Then what do we have? We can remove this by saying by saying that T1 over T2 equals to 1 over root 4L1. So 4L1, can it not be 2? It can be 2. So we have T1 over T2 equals to 1 over 2L. So L has been cancelled. Remember that L has cancelled L here. So I'm not even supposed to put L here. So it's just 4. And root 4 is what? 2. Just trying to break it down. So if I cross multiply here, what do I have? I have 2T1 equals to T2. So T2, that is the period 2, will be equals to 2 period 1. 2 period 1. And what was the answer? Their question was that its period is increased by a factor of what? So if we have 4 times 4 of length 1 of L1, what will be period be increased by? It's going to be increased by what? By 2. So this is the answer. D. It's going to be increased by 2. Is this looking very confusing? Is it looking very confusing? Okay. No response. Because our T will increase by 2 if our length is increased by 4. Because of this formula that T equals to the root of L. So it's going to be increased by that. Okay. Any question about this? Simple pendulum has also been broken down, and the complexity and all that has been sorted out. You can visit it and look at it again. In what range of temperature is the expansion of water anomalous? Anomalous expansion of water was quite explained as one of the basic concepts why water will freeze on the surface. And if you look at an ocean, during their winter period, the surface of the water will be frozen, and underneath, water will still be liquid. Imagine what kind of concept is that? It will still be liquid underneath, but up it's already frozen. And that is why whenever they tread very careful whenever they are walking on ice, because it could break and you can drown by them, because the underneath is still what? Is still liquid. It's still liquid. It's still liquid. So, but on the surface, it has turned to a solid phase. It has turned to a solid state. Why? Because the anomalous expansion of water is a property of water whereby it expands instead of contrasting when temperature goes from 0 to +4. When temperature goes from what to +4? From 0 to +4. That is when we have that basic property of water. So it is from what? Is in what range of temperature is the expansion of water anomalous? It's not supposed to be, and that's why it's abnormal. So we call it what? Anomalous. And that is this 0 to +4. Between 0, between the temperature of 0 degrees Celsius and +4 degrees Celsius, water behave somehow. So instead of it to liquefy or get, it's going to freeze. It's going to turn to solid. But after it has passed this temperature, it becomes normal again. Okay, let's look at the next one. Do you have any question on that? We can read it up on our website. Okay, it said which of the following statements about radioactivity is true? This one brings us to radioactivity. They say alpha particles are positively charged. Okay, who agrees with me? Beta particles are negatively charged. Okay, who agrees with me? Gamma particle is neutral. Okay, who agrees with me? Beta particle has the same mass as helium. Who agrees with me? Gamma rays is charged. Gamma rays is charged. Who agrees with me? Okay, so how true is this guy? Beta particle has the same mass as helium. Is that true? Helium is what? He24. So this is not for helium. Instead, beta particle is what? Electron 0 minus 1. This is beta particle. And gamma ray is neutral. That's correct. It's correct. So this is positive, this is negative, this is neutral. This is wrong, and this is wrong. So which one are we picking? 1, 2, or 3? 1, 2, and 3. Where is it? 1, 2, and 3. See how we are able to eliminate the ones that we don't want and focus on the ones we want. And how did we also get this? Study. Get a material that can help you. SciAfrika is with you on that, and we have provided a solution for that. Study about it, and we can know that. Okay, next question. If there are no questions, he said in the study of physics, temperature and heat are often confused with each other. That is true, and JAMB knows that. So if you are confused as a student, you see that JAMB is catching you now. Okay, temperature and heat are confused with each other. Which of the following statements correctly define these two elements? Temperature is a measure of the average kinetic energy of the molecule of a substance. Okay, let's look at another one. Heat is a measure of the total kinetic energy. Okay, this one's the average. Look at their difference, what they said. This one says total of energy in the system. Okay, this one says different material require different amount of heat to cause a given change in temperature. Different material requires different amount of heat to cause a given change in temperature. Okay, all of the above. I would have loved to throw this to our students to know if they are following. What would you pick? Any students? What would you pick if you were sitting for this question? Let's know if you are confused or you are not. Before we said temperature is the measure of average kinetic energy of the molecule of a substance. Heat is a measure of total kinetic energy in a system. Different material require different amount of heat to cause a given change in temperature. Then the other said all of the above. What would you pick? Let's give you that opportunity to pick this. Anybody? Please let me check if anybody has raised his or her hand.
No one is raising his or her hand.
Ah,
I think we can.
okay, okay. Okay, so the answer is all of the above. They are both temperature is correct as defined there. It is correct as defined there, and this is the most correct, Different substance need different work, need um different heat at a given change in temperature. So the difference is that all is correct about them. It talks about total kinetic heat. Temperature could talk about the average kinetic energy, of that molecule, of that molecule. And that is that. Okay, so this one needs a diagram. So this one needs a diagram, and I was trying to draw the diagram, and for I would it's down. Let's see if we can get there. So for now, permit me to skip it for this question. And remember that once you see a question like this, a closing of the key in a circuit, we are talking about what? Electricity. Electricity, please. So permit me to go for the diagram down on the board. Before then, let's just look at others that have their workings here. So which of the following statements on the use of X-ray is incorrect? On the use of X-rays is incorrect. Which of the following statements on the use of X-rays is incorrect? They said number one is in a hospital to obtain photographs of tissue and bones in the body. So it is used to obtain photograph of tissue and bones in the correct. Yes, I think maybe you agree with me or not. Let's see how correct that is. For the treatment of malignant growth of cancer, okay. To detect fingerprint, how real is that? To review hidden flaws in metal casting and welding joints work of arts. Yeah, so which one is not correct when it comes to X-ray? Have you ever seen X-ray used to detect fingerprints? X-ray. Okay, so our answer is like it's the C. So we can use it to detect metal casting. We can use it to treat cancer cells. We can use it to obtain photographic rays. Under which of the following condition is work done? Aha! This is another topic we actually dealt with extensively when it comes to SciAfrika apps and solution. So we said under which of the following condition is work done? Number one, a boy push onto a table. Okay, when a boy push onto a table, is work done. So if we have a table and a boy push it, sorry, don't mind my diagram of a boy, and he push that boy and he push that table over this distance. Okay, a stand on a table, a stand on a table. So our same table, I hope our table will take the stand, a stand on a table. Okay, this is another one. Is this work done? A man supporting a heavy food, support a heavy food above his head. Okay, a man, a heavy bag of rice that they are selling 10,000 naira now at custom office. Forgive me. they put it on his head. Is work done at this point? Or a woman holding a pot of water. Okay, a woman now hold a pot of water, just holding it. Is work done? Which of this is work actually done? Which of this is work actually done? If you look at this, what is the formula for work done? That is where you should start from. Work done equals to what? Force times distance moved by the what? Times distance moved by the force. Force times distance moved by that force. So where is force applied here? Is force applied anywhere here? What is applying here should be G. And what is applying here? Is there any force here? Maybe it's also G. Is any force applying here? Is he applying any force? Because, and is he moving? He's not just applying force, but is he moving in the distance of that force? Is this thing moving? Just holding a pot. Is it moving through a distance? No. No movement in it through a distance. Yeah, the man is just standing and putting bag of rice on his head. That is all. No movement. No distance. This one, no distance. This is only the place that we can see that when you push this table, it's going to move from here, probably, to here. And so there is a distance in the direction of the force that he made. And this corrects the answer. And this corrects the answer. I don't know if I can stop here to find any question concerning this that we have explained. Is there any question from any of our students? Any question at
I'm
all?
good. Yeah, that's the
Okay, okay,
question.
okay, okay. The next one says something. He said, natural Radioactivity consists of emission. So, what kind of emission? That's the question. Does natural radioactivity consist? We will give you permission. We will give you the privilege to answer at least questions, please, so that we know that our students in South Africa are not, they are good. They know what they are doing. They are prepared at some point. Um, a good a good learning environment is not just teachers teachers concern. It's not just teacher concentrated. It should not, the educator should not be the only person saying it. Let us hear your idea. We want to know what you have, and we know you have a lot to say. So this is an open platform. They can even hear us anywhere in the world, and we are not hiding anything. Even you can also tell the world what you know. So it's not, please speak out. If you know it, then say it. We only boost your morale. We can't bring you down here in this place. So please, this is alpha particle, this is beta particle, this is alpha particle here, this is X-ray, and this is alpha particle. Sorry, this is gamma particle, and this is alpha, beta, and gamma. So which of these are natural radioactivity consisting of emission? What are the emissions from natural radioactivity? That's the question they are asking us. Anybody from the students? We want to hear from you. This question is gotten from where, first of all? You can text it to somebody on our Facebook page. Maybe they are typing, we can ask, we can check that too if they are typing the answer there. They don't want the world to hear their voice. Okay. This question is gotten from what topic? Is quite very simple to know. Radioactivity. That's it. But what is now our emission that we can find from radioactivity? Will you rather choose A or B or C or D? Anybody? Our students are good students now. Nobody wants to talk. Sir, what did you say? I think someone wants to talk.
I think it's the alpha particles, beta rays, and gamma rays.
Hello, sir. What do you say, sir?
I said I think the answer is D. Alpha
Yeah,
particles, beta rays, and gamma rays.
you are you are super correct, sir. You are super correct. That's amazing. You are super correct, sir. So there is no point hiding what you know. You are super correct. Don't think again. The answer is actually D. So don't think the answer is D. The answer is actually D. Particles, beta, and gamma. That is it. If you are choosing this one, you will be partially right. If it's not correct. If you are choosing this one, no. If you are choosing this one, no. But this is the right answer for that question. We can find that when we are looking at radioactivity. And what is radioactivity for your understanding sake? Radioactivity is the spontaneous emission of radiations from atomic nuclei, when they disintegrate, then they emit some particles, and these are the particles they emit. Chemistry should do more justice to this. Chemistry, our chemistry lecturer should do more justice to this. Well, let me move on. And instead, if a source of solid is moving, a stationary listener can hear a sound of different frequency higher. Look at this. This is beautiful questions. And many students, and that is why this is the difference between JAMB and WAEC. JAMB goes deeper than WAEC. Now, at any whole level, yes, you should be able to do this, but But if you don't read deeper, you will never know what these questions are. You will never know what this question is. And what is this trying to say? It says that if a source of solid is moving, a source of solid is moving, a stationary listener, a listener will hear a sound of different frequency. A sound of different, whether high or low, will be heard by a person that is that is standing. No wonder when a power bike pass by, I just hear vroom, and the way it's gonna sound, or these when you are in a racing competition, you know, the sound coming will tend to just fluctuate, and before you know, you will not hear it again because you are a stationary listener, moving at that point. So what is this effect called? Is it a Doppler effect? Is it a resonance? Is it an ultrasound? Is it a rarefaction? What is it really called? Yeah, resonance. Resonance is when one body's frequency causes another body, to move at its own frequency. That's resonance. That's where we use the tuning fork. I don't know if you guys know the tuning fork effect. That's resonance. We cause one body to move at its frequency of another body. That's resonance. That's it. It's not ultrasound is when you go deep down into somewhere unseen or deep with a sound effect and you are able to receive a response from that sound. Rarefaction is when a wave does what pass through a bend, that's rarefaction. So what is Doppler effect? What is now the Doppler effect? So I think we have been able to extract this as a wrong answer. So what is now Doppler effect? Doppler effect is the change in frequency of a wave. Frequency. So this one really deals with what? Frequency of a wave in relation to an observer. In relation to an observer, which is moving relative to the wave source. Which is moving in relative to the wave source. So our answer is actually Doppler effect. So Doppler effect is what you would pick if you find yourself in this question. So Doppler effect actually is that experience that you get as an observer when you are hearing a sound, a wave coming, and it really affects the frequency. The effect is on the frequency of that wave and not on maybe the wave speed, or the wave period, or the wave pitch. It is basically on the frequency. This one allow the frequency of one to affect the frequency of another. That is resonance. Okay, can we move on? I think we are just done. We have done about 13 questions or 14. I don't know. I feel like do we still have time, sirs? Okay. Okay, so
Yeah, I think we still have like 10 more minutes more to go.
okay, sir. Okay, sir. So let's look at this question. It said, which of the following can be described as high tension transmission? High tension. Wow, this question in physics is even related to our basic life. Some of us in our house we have high current. What is really causing it? What is really the issue? Was it the voltage? Was it the resistance? Was it what actually is the problem? He said, which of the following can be described as high tension transmission? High tension transmission. Is it a high resistance or a low voltage? So when resistance is high and your voltage is low, is that when you have high tension? I don't know if we all get it. Is it when we have low current or when we have high voltage? And when we have high voltage, is this when we refer to as high tension? Or is it when we have high current and low voltage, or high current and low resistance. So which one actually? Which one actually? How many of us remember our basic Ohm's law formula? V equals to what? I. That is, V is direct proportional to either of them, but I is not. If I should make I the subject of the formula, what would it be? It's going to be what? V over what? Over I. It means that it is indirectly, current should be indirectly proportional to what? To I. Meaning that if current goes up, resistance should come where? Down. I don't know if you guys are getting me here. If current goes up, resistance, it means that resistance is what? Is down. So at what point do we have high tension light? So it means that if current should be high, very high in any area, it means that the resistance is what? Is low. So our answer, low current, high voltage. High voltage, because voltage also current. This is quite normal, but current is also direct proportional to what? To voltage. Yeah, it's direct proportional to voltage here. So if current is direct proportional to voltage, and here we have high, low current, high voltage. This is the answer. The resistance should come down whenever we have high current. That is normal. This is normal. But when we have high tension transmission, which is quite not very, 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 normal, or we need it at a specific time or period, it means that we tend to increase our voltage and reduce our current. And when we have this, there is a transmission called the high tension. Any question? There's a question on electricity here too, so we need to answer. So high tension is a relationship between current and voltage, not current and resistance. It's a relationship between current and voltage, not current and resistance. The resistance in the wire can be static and can be varied, or in the circuit can be static and can be varied. So we might not be able to move that, but we can increase our voltage and we can tend to reduce the amount of current. And whenever we have a high tension, it means that current is low and voltage is high. There's this question here. As low as the class that attends these questions are, many seniors, they brings it out. It always come out almost every time we JAMB. And why? Because they know that many of you would have forgotten the topic under electricity, that is converting it, rating the power, at what cost will power cost. That's what they do. Okay, so let's quickly look at it in 1 minute before we end this. So what is the cost of running 550 watts? So 5 times 50, 550 watts, and 400 watts for 10 hours. So what is our power of that house? The power in that house is 5 times 50. Remember, 550 watts plus 400, 4 times 100 lamp. time. So all of this will give me what? Will give me 650 watts. 650 watts. That's what the power of that house is. And I'll say, if I run them for how many hours? 10 hours. If electric energy costs 2 kobo per kilowatt, so 1 kilowatt hour will cost 2 kobo. 2 kobo. How much will running this 650 watts cost? I need to convert this 650 watts to kilowatts because this money is rated in what? Kilowatts. Kilowatt. So if I want to convert it to kilowatts, what is it going to be? And also with time. Remember, with time. If I want to convert it to kilowatts, what is going to be? I'm going to do it by what? By 1000, right? It has been converted to kilowatts because I divided by 1000. So, but I can't use power because it has to be, I have to make it energy. So what is energy? Because I have to add it with time. I have to multiply it with time. So our energy equals to what? Power times time. So power has been converted to kilowatts times 10 because I divided by 1000. Our time here is 10 hours. I can't use power. It has to be what? Because it has to be 5 kilowatt hours. So hour. What is 6.5 kilowatt hour? So if we have 6.5 kilowatt hour, so 1 kilowatt hour power times time. So hello, power said I'm no longer sharing. Can you see my screen? Times 10. Our time here is 10 hours. So
No,
can you see my
no, no,
screen?
No,
no, no, no. I think you should share.
6.5
Kindly share your
kilowatt
screen, please.
hours. Hour. 6.5 kilowatt hour. What about now? 6.5 kilowatt hour. 1 kilowatt hour.
Yes, we can see now.
Okay. So hello, so it's 6.5 kilowatt hour. Can you see my screen? So if we have that as our energy, so we have 1 kilowatt hour.
No,
Can you see my
no, no,
screen?
no,
Kobo. So
no, no. I
what
think you should
will
share. Kindly share your screen, please.
6.5 kilowatt hour give us? Okay. What about now? If we cross multiply, it's going to be what? X will
Yes, we
be
can see
equals
now.
to 6.2. So it's 6.5 kilowatt hour. 2. So if we have that as our energy, so we have 1 kilowatt hour equals to 2 kobo. So what will 6.5 kilowatt hour give us? Can anybody, if we cross multiply, it's going to be what? Help calculate that. Equals to 6.2. Any of our students? 6.5 times 2. So okay, so we have 13. Answer. So that's going to be 13 kobo. 13 kobo. So do we have any option of 13 kobo? Oh, yes, this is it. So our answer here is what? D. Help calculate our answer that. Here is D. So thank you very much. I don't know. Okay, so we have 13. So that's going to be 13 kobo. Some questions here, but do we have the luxury of time? Do we have any option of 13 kobo? Oh, yes, this is it. So our answer here is what? D. Our answer here is D. So thank you very much. Hello, sir. I don't know. We still have
Hello, Mr. Boak.
some questions here. Yes, but sir. Do we have the luxury of time to go ahead with them, sir?
I think we can still have like maybe more, maybe in the next 5 minutes or 10 more minutes.
Okay. So our next question says that hello, sir. The mass of a proton is approximately equal to that of, we have looked at
Hello,
it
Mr.
when
Boak.
we were looking at yes, sir. Up
I think we can still have
when
like
we are
maybe
looking
more, maybe in the next 5 minutes or 10 more minutes.
up there. So okay, is it so? Sorry for this. Our next question says that yeah, it the is mass of a alpha. Proton, yeah, it is beta. Approximately equal to that of. So we have looked the at mass it when of we were proton looking at is approximately equal to that of what there. So is it that of, sorry for this one, is alpha particle, alpha, that of beta particle? Remember we said beta. Alpha particle is helium. So mass of proton, is it the same thing as that of helium? Is or approximately that of beta particle, which is that of electron, minus 1 and 0, or neutron is this, is it that of and 0, and electron is this alpha particle, that of beta particle. Remember we said alpha particle is helium. So what is it approximately on with? It is approximately on with neutron. So mass of proton is the same that of beta as mass of neutron. It is electron that has lesser mass, 1 and 0, and that is about 1 over, is it 1850000, an electron less in mass than both of them. So they are equal in mass, approximately. What is it approximately? Okay, I'll take this calculation. It is approximately on with neutron. So mass of proton is the same as mass of neutron. It is electron that has lesser mass, and that is about a transformer has 300 times 0000. Less transformer has 300 tons of wire. They are equal in mass. 300 tons of wire. Okay, the primary, I'll take this calculation and so this is where we need to go and study about transformer, about the transformer in the primary coil. A transformer has 300 secondary coil. If the input voltage is, the transformer has 300 tons of wire. The input voltage 300 tons is 100 volts. So I think the primary coil there is a mistake there. So we cannot find, we need to go input voltage and said we should find another input voltage. So let me correct which one they really want us to secondary coil find. If the input voltage is one, output voltage is the one they want us to find. If the input voltage is 100 is the one they want us to find. So I think there is a mistake there. If the input voltage is 100 volts, what is the output? Find another input voltage. So let me correct which one they really want us to. What is the output voltage? Remember, output voltage is the one they want us to find. Output voltage is the one they want us to find. The formula of transformer is so straightforward. If the input voltage is 100 volts, what is the output? It's not complex at all. It's not complex at all. Voltage. What is the output? You can say it as voltage. Remember that number of turns of secondary divided by number of turns for primary forward. What do I equals to by so straightforward is not complex at all. Remember that it's not complex at all. Let me quickly draw this and you can see it as foundation. Number of turns, this is of secondary divided by this is number of turns for primary equals to, if this is input and this is output. Remember the number of turns in this is called primary. Quickly draw this primary. So NP is here, NS is here. This is secondary. This is to EMF output that we know as volts too. This is secondary EMF that is ES. If this is input, why this place is output EP. The number of turns in ES this is called primary. I don't know if primary. So NP is here. What they are saying. So this is NS over NP EMF that we know as volts to ES. This is over secondary EMF that is. This is the formula we can use to why this place is what the number of turns and ES. So number of turns for S is what we secondary coil. We have 30 divided by number of turns for primary 300 NP equals to ES is what we are looking for. EP and divided by one formula we can use to. So if we do this very well, we are going to have ES and ES equals number of turns for S is what divided by 3 secondary coil. We have 30 1 divided by number of turns for primary 300 10 volts equals to, is this a step up transformer or a step down transformer? I think that should be another question. Divided by 1 for the D. If I was if we do JAMB, that's what I'm going to ask you whether S equals to 3 1 2 3 divided by 300. 1 2 someone is trying to join again. What we have 10 volts. So our answer for this question is step down transformer. I think that should be another question. Thank you so much. D. If I was JAMB, that's what I'm going to ask you whether the guy is unverified giga charge. Should I deny? Someone is trying to join
That who is
again.
that?
Okay.
Yeah,
Someone
don't worry,
wants
I've
to
done
join
that
in,
on
but
my
our
on my
answer for
end.
this question is 10 volts. Okay, sir. We can see that. Thank you. So that about transformer. Transformer is very interesting topic, and
Giga chat.
that is how
Should I deny?
we solve it. That is just one of its formula, though.
That
It's
who
just
is
one of
that?
its formula. And we have been able to look at that.
Yeah,
Someone
don't worry,
wants
I've
to
done
join
that
again and
on my end.
okay. Okay, sir. So what is this question? So it says that about transformer. Transformer is very interesting
solid
topic,
way
and that is how we
4
solve
points.
it. That is just
8
one of its
gram
formula,
in
though.
air, 2.8 gram in
Formula.
water,
And we have been able to look
and
at that.
3.2 gram in kerosene. Okay. The ratio of density of the solid to that
What
of
is this
kerosene
question?
is what?
It says
The
that
ratio. So we are going to be looking at ratio. The ratio
solid
of
weight
that of what?
4 points
Density of solid to
8
that of
gram
kerosene
in
is
air.
what? When we hear ratio,
2.8
it's
gram
not a
in
big
water.
deal actually. What is it
And
just saying? It's just
3.2
trying to
gram
say
in kerosene.
division.
Okay.
The ratio of
What's
density of the
what are they
solid to
sharing?
that of kerosene
Is
by
what?
what division? The ratio. So
Are
we
they
are going
related?
to we are going to be looking at
The
ratio.
formula for
The
density
ratio of that of what? That's where we start from. Equals to density of solid to that of kerosene is what? When we hear ratio,
solid
it's not a big deal actually. What is it just
over
saying? It's
weight
just trying to say division. What are
of
they sharing?
an
What
equal
by what division?
volume
Are they
of
related?
water.
That's just what it says.
The formula for
Weight of the
density
solid and weight of the equal
that's where we
volume of
start
water.
from.
So by this
Equals
definition,
to weight
density of this solid is going to be what?
of
What
solid
is the weight of the solid? They have given us in
over
air.
weight
They have given us at what? 4.8.
of
And what is
equal
that solid?
volume
Um,
of
by that
water.
same equal volume of water, what are we going
Weight
to
of
do?
the
We are going
solid
to say
and weight of the
4.8
equal volume of water. So by
minus
this
when
definition,
it was
density
weight in water
of this solid
minus
is
what?
going to be
Minus
what?
2 point
What
what?
is the weight of the solid?
2.8.
And
They have
that is what
given us in air.
4.8 over
They have
2.
given us because if we minus
That's what
this together, it's going to
4.8.
give us 2. And the 4.8
And
point
what is that
divided by 2 is
solid?
going to what? 2 point what? 4.
By
That is
that
the
same equal
density.
volume of water,
You
what
know
are we going to
that
do?
we are
We are going
looking
to
for
say 4.8
of that thing. But we are not
minus
done.
when
We
it
have
was
just
weight
done it
in water
in water.
minus
But
what?
they have said
Minus 2
also
point
in
what?
kerosene. So
2.8,
how do
and
we
that is
do
what
it?
4.8
Because now the
over
relative
2. Because if
density
we
in
minus
kerosene.
this together,
What's
it's
now
going to give us
density
2.
in kerosene?
And
Relative
4.8
density divided by 2 is going to be what? 2 point what? In kerosene.
we
That is
use
the
the same
density formula.
you
But
know
this one is going to
that
be
we are
weight
looking for
of that thing. But we are not done.
of
We
liquid,
have just done it in water.
which is what?
But they have
Kerosene.
said also in kerosene. So how do we do it? Because now
Which
the
weight of
relative density in kerosene.
yes,
Now
weight of that
density in
liquid
kerosene.
divided by
Relative
what?
density
Weight of
in
an
kerosene. We use the same
equal
formula. But this one is
volume
going to be weight
of water of
okay.
liquid,
So how can we find that relative
which is what?
density of that
Kerosene.
kerosene? We know that the solid weighs
Which weight
4.8
of
in air. But when it comes to kerosene, what
yes,
did
weight
you
of
weigh?
that liquid 3.2
Divided by
so we
what?
can
Weight
gladly say that 4 points of an equal
Someone
volume
want to join again, please?
of
So
water
4.8
okay
minus. So how can we find that relative
minus
density of that kerosene?
that's what
We
it
know
weighed
that
in kerosene,
the solid
and that is
weighs
minus what?
4.8 in air.
3.2
But when it comes to
divided by
kerosene, what did it
what
weigh?
it weighed
3.2. So we can
4.8
gladly say that
and
4
what it
point.
weighed in water, and that is what? 2.8. And when we do
Someone
this,
want to
we have
join again, please?
1.6
So
divided by 2, and
4.8
that is what?
minus
0.8.
just follow
Minus
me. We have had two values,
that when what
2.4,
it weighed
and we have
in
had
kerosene,
0.8. So
and
what
that
is
is
now
minus
the
what?
ratio between them?
3.2 divided by
This is when
what
it is
it
in
weighed
water, and this is when it is in kerosene. And what did
4.8
they say? They say
and what
what is
it
the
weighed in
ratio of the
water, and that
density
is
of
what?
the solid
2.8.
of that
And
of
when we do this, we
kerosene
have
is
1.6
what is now the
divided by
ratio?
2, and that
What
is
is the
what?
density of the
0.8.
solid to
Just
that
follow me. We
of
have had two
kerosene?
values, 2.4,
Remember
and we
that
have had
it is
0.8
first of all
weighed
what
in
is
water,
now the
then it was
ratio
weighed
between them
in kerosene. So
their
this is
ratio
when it is
is
in
going to
water,
be
and this is when it is in kerosene.
and what did they say? They say what
Density
is
of
the
solid
ratio of the density
over
of the solid
density
of that of kerosene
of
is
kerosene.
what is now the ratio? What is the density of the solid to that of kerosene? Remember that it is first of all weighed in water, then it was weighed in water.
Kerosene.
So their
Divided
ratio
by
is going to be density of solid
over
in
density
kerosene of kerosene, and that will be what? 2.4 divided by what? 0.8. If we divide this, I think it's going to give us 3. Am I correct? 3. What's the answer? In water, we have 2, we have 32, we have 23. We have 3. Or solid is going to be our answer. In kerosene. And that will be what? Okay. 2.4 divided by what? 0.8. If we divide this, I think it's going to give us any question? 3. Am I correct? Do we have any question? What's the answer? We have 2, we have 32, we have 23. We have 3. My battery is going to be our answer. Do we have any question? Mr. Anishi.
Okay.
Any
Oh,
question?
thank you very much, Mr.
Any
Boaz.
question?
We really appreciate
Do we have any
your teaching,
question?
and we believe students on the platform from the beginning will truly enjoy the lecture. Or I think the only person we are having now is
Do we have any
Ozioma.
question?
Ozioma, are you still here?
Mr. Anishi.
Yeah.
Okay. Do you have any question? Or
Thank you very much, Mr. Boaz.
what will be your
We really
comment? Did you enjoy
appreciate
the section
your
or what?
teaching,
And we believe
Yeah, I
let's hear
really
from you.
enjoyed it.
Students on the platform
I
from the
enjoyed it.
beginning will truly enjoy.
Please, in the
the
next
lecture.
next
Or
week,
I
kindly
think the only
notify and
person we are
invite
having
your
now
friends.
is
So then we'll
Ozioma.
be
Ozioma, are you
treating
still here?
questions on biology,
Yeah.
and that is how we
Okay. Do you have any
till
question or
your UTME.
what will be your
I will
comment?
pray
Do you
you all
enjoy
will
the
come out
section
in
or
flying colors by special grace of God. So
Alright.
thank you. We are going to be ending this learning is fun for today here now. So have a wonderful time.